Okay, let us begin. So, I've got another exam up. We are, of course, still doing exam revision. This time it is the 2022 Tech Free exam. No CAS. The first couple of questions of those are always the same. Diff, and then some other kind of diff. In this case, it's literally just two sets of f-x's. I feel like at this stage we can probably just leave these questions to for own private study because it's the same thing every single time. Yeah, so let's just make a move on with question 2 instead. Unless, of course, is there anything you want me to specifically have a look at before we dive into the exam? Were there any questions you came across? Okay, I've seen your thing light up green, but didn't actually hear what came through.
I don't really have any questions right now, so
Yep, awesome.
should be good.
All right, let's make it through these then. Now, part A is also basically a pretty basic diff/anti-diff type thing, but it will become important for solving. Oh, actually, no, it doesn't even look like it. It's f of x. Yeah, why not? We'll just do 2a anyway. So, yes, I should probably also put in the actual exam. So I'll grab both of those, exam and solutions doc. Yeah, so you can go at your own pace, or as necessary. Starting with 2a though. Ah, damn it. I gotta send it again. I've really gotta figure out how to make this a persistent chat. I can, like, I don't know what's different about the settings where I can see the full persistent chat but no one else can. Very strange. But yeah, for everyone just catching up, we're on 2a right now.
Chris, is it 3 natural log absolute 2x minus 3?
Not fully. That's not the full answer there.
Plus C.
Plus C is also part of it. There is one other thing missing. Did you have a divide by 2 in there?
Oh yeah, my bad. Yeah.
Yeah.
Sorry.
Okay. Now, absolute, is that cool? They did say find an antiderivative. It wouldn't be the most accurate answer. Like, putting an absolute in there doesn't hurt. It doesn't make it wrong. But because it's only defined for 3 over 2 to infinity, you can actually choose whether it's the positive or negative version of that log. And so to be as accurate as possible, yes, I get that you put the absolute in there because that catches all outcomes. Because it's only pointing right, you can actually use the positive version of the log instead. And so yeah, just doing 3 over 2 natural log 2x take 3 with the plus c. That's all that's required there. Cool. Okay. Next up, part B. I'll actually write out that full answer as well, just so we can all be on the same page as to what that was. 3 over 2 natural log 2x take 3 plus c. That plus c is important because it says... Actually, I should double check that. Yeah, okay. The key wording around this is a bit nuanced in the sense that it says find the rule of an antiderivative. So technically speaking, plus c isn't a major requirement there because if you set c equals 0, that is an antiderivative of g. It's one of many possible antiderivatives of g. And so the plus c isn't necessarily required in that one. I've had a look at the actual official exam report in there, and they say it's fine to leave it off. So just figured I'd clarify a bit of a nuance around that one. It's a pretty common question that comes up quite a bit in multi-choices, actually, in a tech active, where they'll tell you to solve one integral and then give you some known values of related integrals. So even though you don't know what f is, you do know specific definite integrals of f that you can then use to solve the one that you want to solve.
Chris, could we expand the expression inside?
I would certainly do that. Yeah. Distribute the f of x into 2f of x and the minus 3. Good start. Getting a lot closer to being solved now. You might notice some similarities. Like, for instance, we know the integral of f of x squared is 1 over 5. We also have an f of x squared in this. We know the integral of f is a third. We also have an f of x in our integral as well. So the goal is going to be to find a way to make use of those values. But we have to do
Chris, is the answer negative 3 on 5?
the answer is negative 3 over 5. Yeah, precisely. Maybe walk through a bit about what you did to get there.
So I expanded the expression, and then I got an integral of 2f of x squared minus 3f of x
Yep, that's good.
over, and so I just plugged in the values. So since the integral of f of x squared over the like bound specified was 1 on 5,
Mm-hmm.
then that means that like the first part of our integral is 2 on 5.
Yep.
And then so obviously I split up the integral as well just to
Yeah,
didn't.
that's what I was looking for there. Yep, splitting up
And
that
then
integral. Nice.
then when you subtract the integral of 3f of x, 3 times the integral of f of x should be just 1 because 3 times 1 on 3.
Yep,
And then 2 on 5 minus 1 is negative 3 on 5.
solid. Yeah, So if I show on the screen share there the full working out that would probably correspond to, there's the 2f of x squared minus 3f of x, and then here's the splitting of those two things. So you can split between the plus and minuses. I even went ahead and brought the 2 and the 3 out so you could very clearly see, I have this, so it's that. I have this, so it's that. And then yeah, simplifying the fractions. Nicely done. Anything to clarify there at all? Let me know. Otherwise we got part 3 going on. This is also a very common question for a tech-free. System of equations, solving for either infinite solutions, no solutions, or one solution. Very common thing. There's a few ways you could do this one as well, depending on how many of you also ended up doing general. You might like a matrix approach to this sort of thing, using matrices. It's not really in the method study design anymore though, so I'd be surprised if I see it. But it's technically doable. For anyone still stuck, consider what infinite solutions means. These are two linear equations. You know they're linear because there's no powers of 2 or anything else in there. Consider what it means that two straight lines have infinite solutions between them, what physical criteria need to be met, and that can help you figure out K that would make that happen. The way I typically teach it is to get both of them in terms of y equals mx plus c, and then make sure the gradients are the same and the y-intercepts are the same. because when you have that, you have two equations that are identical. Infinite solutions means that your two lines are perfectly overlapping. So if you do your rearranging for y equals mx plus c, compare gradients, compare y-intercepts, figure out which k value would cause them both to be the same. Or at least, figure out which k value will cause both gradients to be identical and both y-intercepts to be identical. They don't all have to be the exact same number, just within gradients the same and y-intercepts the same. Is anyone close to an answer, or shall I start going through some of the solutions?
I got -3. Okay,
-3? Yeah, you did. Nice. Good one. Perfect. So yeah, the solution I'm going to show you is exactly that. Just out of curiosity, did you do more or less what I was doing?
Yeah, I did exactly what you were doing.
Yeah, sweet. Yeah, so infinite solutions, both equations have to be identical. Oh shit, I've got the determinant here. Oh no, this is an old document then. This is what I was talking about with the with the matricey stuff. Uh-oh. Oh no, I don't even have it here. It's just determinant. Sad. Okay. But yeah, rearranging for y equals mx plus c on both of these, and then comparing the... You'll still get the exact same sort of equation. I'd imagine, did you get that equation there? K squared plus 8k plus 15?
Yeah, I did.
Yeah, so it's just another different way of getting to the exact same spot. The only thing I can't really show you there is the y equals mx plus c rearrangement, but that's not really all that challenging there. Yeah, that's about it there. Cool. Here we go. Probability now. Question 4. One of the first things you're going to have to consider is which of the probability types do we have? Discrete, binomial, normal, continuous, or sampling and estimation. It's going to be one of them. That'll then inform how you solve the rest of the question. Yeah, binomial, that's right, Pierre. Nice. You got your 50-50 shot, red or blue, two possible outcomes. And then the independence clause in there also tells you, all those things tell you binomial. Nice. I'll also say there's a bit of a cheat with this one, oddly enough. There's a bit of a cheat specifically when you have binomial distribution where there's 50-50 outcomes. 50% for the first outcome, 50% for the second one. It makes filling this whole table a lot easier. Or one, yes. Yeah, correct. So you've got this mirroring that's essentially going on, which is a binomial distribution where p is 0.5 is going to be symmetrical starting at the center, kind of like how normal distribution is symmetrical starting at the center. So if you figure out the x equals 1 probability, you figure out the x equals 3 probability. Just like you got it there. Yeah, 4 out of 16. Obviously, you then simplify your 4 out of 16, but otherwise, yeah. And you don't even need to solve x equals 4 because you've already got it over here, 1 over 16. Now, that is a bit weird, actually, now that I'm looking at this. They didn't seem to simplify their 6 over 16. You still want to simplify your answer. It's a bit weird they didn't simplify theirs. Huh. Even in their... That's also weird. Even in the VCAA prescribed thing, they also had 4 over 16 there. What's going on? Do they say a clause in here that makes you able to do that? Hit table. That's a bit weird. You'd be safer to simplify the probabilities. I'll just leave it at that. But yeah, so to sort of see what that was all about there, Bernoulli sequence is how you calculate your binomial probabilities. So you would then go through your Bernoulli sequence. This is on the formula sheet. The formula sheet look a bit different now, not too much. You get... Yeah, this is probably a bit too old then for a formula sheet. Nowadays, you get the Bernoulli sequence on your formula sheet. Doesn't look like it's here, unless I've gone blind. But yeah, that's all that one is. So Bernoulli sequence, simplify your n equals 4, r equals 1, and then that's going to give you everything you need to do your flips, or you can then go ahead and calculate them all if you don't see that shortcut. If there's any questions, feel free to let me know. Otherwise, part B.
Is Poppy 1 on 8?
Not as a final answer, 1 on 8, no. What was your reasoning there?
Also like because independent events. So you want two like reds and then one like red complement and then all those like probabilities of off and you multiply them together as 1 on 8.
Repeat that last bit, sorry.
Like because you want two red cards, right? And the
Yeah.
probability of picking a red at any time is gonna be half because it gets replaced.
Yeah. Yeah.
The same for blues. Then if one time we want red and then two times we want red and one time we want blue, then I thought that it would be 1 on 8 because you multiply the probabilities together.
Yeah, so that's going to be part of it, doing that type of arithmetic. Now, this doesn't say that you have to do red, red, blue. You could do that in any order as well. So it's 1 out of 8 for any one of those combinations. There's 3 ways that you could arrange those things. And so it becomes 3 over 8. So you're mostly right there. You just got to remember that the ordering in which you do things can also play a role there, which is this sort of shortcut that I'm describing here. The other thing you could have also done is, have like a winner soldier moment and see the keyword given and think, oh, yep, we're doing conditional probability. And so you can just sort of smack that out using conditional probability methods, which will also get you there. Again, x equals 2 via Bernoulli sequence, because that also accounts for the number of possible combinations in which you could have red, red, blue. Clear enough why we need to consider the combinations in there? If so, feel free to move on to C. Sweet. Yeah, here we go. Same question, but now you can't rely on the on this bit here. Base probabilities have swapped. I think my answers might have a bit of an incorrect statement in there. It still gets the right answer, but I think I made the case incorrectly that this stopped being binomial. Pretty sure it still is. You're allowed to have different probabilities. I clearly wrote this a very long time ago. So just ignore that first sentence if you're following along with the answers, and I'll fix that up. I think it was written to catch out people like me who would, well, past me, who would have seen this split of probability and thought that it stopped being binomial. Because technically speaking, you're solving C the exact same way you're solving B. It's just that the outcomes you're looking at have a different base probability. Anyone close to an answer? Or are we still having a bit of trouble? Okay. Yeah, so it still ends up being Bernoulli sequence. The only thing you're changing, like exactly what you did for B, is what you do for C. Except instead of doing a half and a half in your two spots, we now do 2/3 and 1/3 in your spots. So if you were to do this again, you'd put your 2/3 there for, yeah, 2/3 was red. Yeah, you'd put your 2/3 there and your 1/3 there. That's all you have to do. You could ignore this statement here. I did a bit of a roundabout way of doing that. Your factorial stuff will still simplify down to 3. And then here's your probability of success, power 2. Here's your probability of fail. You got 1 fail. You get your 4 out of 9. Is that okay? Is it clear enough why these are the same question? Exactly 2 of the next 3. Happy to support there. Otherwise we can move on. I'll just be 1 sec while I
Is
take.
x equal to 5?
Oh yeah, you've got it already. Yeah, x equals 5. Was that what kind of approach was that?
Equating exponents.
Yeah, equating exponents. Sure, that's good. Converting 100 to 10 squared, and then 3x minus 13 equals 2. Yep, works perfectly fine. Just for the sake of it, here's another alternative approach where you log 10 both sides and you still get to the same spot. Obviously, it's a bit slower. Taking log 10 and using log laws, a bit slower, but still gets you to the same spot. Cool. Good stuff. And then maximal domain. This one will take some time to have a think about. Now I shall take off my jumper. And I'm back. So maximal domain of a function. Yeah, I'll let that sit for a bit before I give a hint. The first thing you're going to want to consider is basically what type of function do I have here? In this case, it's a logarithm. And so once you identify that you have a logarithm of some sorts, you then need to consider what are the inherent restrictions across all logarithms? Like what would it take to put something in the brackets of a logarithm to break it? That'll then inform how you go from there to figure out maximal domain. But the answer to that is that logarithms inherently need to have whatever's in their bracket greater than 0. So what that essentially boils down this question into figuring out is how can you get your quadratic x squared minus 2x minus 3 to be greater than 0? Because as long as it's greater than 0 for all the x's you give it, then the logarithm will be defined. That would be where the first mark of this comes from, setting up that inequality.
Does x have to be greater than 3?
Greater than 3 is part of the answer. Yep.
And then that means that the maximal domain is from 3, like x is the element of 3 to infinity, with
That does not maximize it. It does, what you've got there is one part of the full domain. Where'd you get the 3 from?
I'm guessing that's just an asymptote, because if you sub 3 into the function, if you sub 3 into function, it's going to be 0, right? So
Oh, okay, so you got the
I think
3
that's that.
from solving for function equals 0?
Yeah.
Okay. Did you get another answer with that?
There should, I think it's like,
Or did
wait,
you
hold
just
on.
kind of guess and check some?
I kind of just eyeballed it because
Yeah, you
I just
eyeballed it.
put 3 into x squared, but there's
Okay.
probably another answer.
Yeah. So get your second solution there, because that'll
I think
definitely.
I think it's -1.
It is -1. Yes, there's two solutions that get you there. So yes, 3 to infinity does work. There's also something to do with -1 as well. Remember, quadratic has two halves that point upwards. And so you want the y values of your quadratic to be positive. That'll also be true of -1 to something.
Is it -1 to -infinity?
Yeah, correct. So to visualize what was going on there, basically you do your step there, which is solving those two x-intercepts, and then plotting the graph. You really only care about the x information in the graph. You couldn't really care less about this turning point. You care about the y insofar as knowing if it's positive or negative, but that already sort of comes through via shape. As long as you know you have a positive quadratic, you know that you have a shape that looks roughly like this. And so from there, because you want this quadratic to be greater than 0, you then look at this picture that you've drawn and say, where is my quadratic above the x-axis? Yes, 3 to infinity is part of that, but so too is -1 to -infinity. So don't fall into the trap that negative x values are always bad, because sometimes you square them and they become positive again. And I've also got this as well. Just don't even worry about this. It's another method of doing it where you essentially look for, it's kind of like null factor law, where the only way this can be positive is if you get positive, positive, or negative, negative. You should be good enough to sketch this quickly, or at least quicker than it would take you to do that whole sign analysis. But it is another method, so why not? There's another tool for your toolbox there.
Are you allowed, is it okay if you just look at it like a composite function?
Yeah, sure. It is a
Cool.
composite function.
Yeah.
Fundamentally it is. So is that more or less what you did?
Yeah, and then I just restricted it to find the subset, which was the
Yeah.
domain. Sorry.
Yeah, brilliant. So how does that workflow actually look like when you do that?
Wait, sorry?
So how does that composite function method actually work that you've done?
Well, the parabola would be the inner function, so the range of that has to be a subset of the log's domain. And then when you restrict that, it's literally just all real positive, which just in turn comes to negative infinity. If you change that back into the domain, it's negative infinity to -1 and 3 to infinity.
Yeah, okay, cool. So you've essentially done, instead of finding your x first and then getting y, you've found the y first and then reversing back to x.
Yeah.
Yeah, solid. Works as well, for sure. There's 3 methods now that you've got to have a look at this. Yeah, composite function stuff works perfectly fine for this as well. Cool. Question 6, drawing the graph. Good news is it's only a small portion of the question. It's going to be hard for us to talk about drawing the graph, so maybe have a go, get a graph going, and we'll compare and talk about it afterwards. Maybe just a thumbs up once you got your graph. Yeah, and don't feel like you need to recopy the graph that's already there. Happy for you to just draw it, draw the new one instead. Although it might actually help. Make use of the reflection of it. Sweet. Okay. Let's have a look. pretty much all you're doing is that. So if you did draw a copy of the previous graph, then doing the reflection of that isn't really all that bad because you just sort of mirror it across the horizontal axis. Out of curiosity, did you label these? Probably not, that would have taken a lot. Did you label these cuts?
No, I didn't because I don't have the grid paper. Like I don't have the actual paper printed.
Yeah, that's fine. I mean, the x-intercepts weren't drawn on the original graph, and so drawing the x-intercepts on your graph wasn't required here, nor did they actually tell you to. They didn't really say label axes, intercepts, or cut points or anything like that. Only reason I say that is because technically you actually end up doing that in part B. Find all the values of k for f of k equals 0. So if you had already gone and done that, you've now got your 3 marks for that as well. But yeah, so to talk about this, draw the graph. It's pure and simple a reflection. There's no translations, no nothing else. So as long as you understand the fundamentals of reflecting in the horizontal axis, then that should have been fairly chill. Happy to clarify though. Otherwise, move on to part B. They did go a bit cheeky here by chucking in k. K is fundamentally no different than if it had said x. I think they were trying to do a bit of a they were trying to divorce it a little bit from this function, make you think a bit harder. It's the only thing I can think of for that. Yeah, looking at the exam report, it was literally just supposed to be a gotcha. Like if you had said x is an element of your solutions, you didn't get the mark. That's a bit bullshit. Oh, whatever. But yeah, the solving circular function.
This is k equal to pi on 12 and 5 pi on 12.
Those are some answers. Yep.
Oh, yeah. Yeah, give me a second.
Yeah, 0 to 2 pi. You can even visually see on the graph that there's more
Oh,
than
yeah,
2.
and 13 pi on 12 and 17 pi on 12.
Yeah, that's all of them. Nice. So, yep, as I said there's ways that you could error check that. You can see there's 4 cuts on the x-axis, so you would expect 4 solutions there. That's one thing to do there. Then just to show how that all works, you'd take your function, make it equal to 0, get it into exact value form. So you've now got the half on one side, circular function on the other. The first 2 angles of that, of course, are going to be pi over 6 and 5 pi over 6. You guys need to have these unit circles memorized if you don't already. But you should have, I guess, earlier on in the year anyway. And, we need 4, so we're going to slap on 2 pi to both of those solutions to get the other revolution worth. We know we want to plus 2 pi because it's forward, right, from 0 to 2 pi. And then only then do we divide everything by 2. Another thing you could have done to make it more bulletproof to never forget the second set of solutions is to do the substitution method, where you rewrite your full domain in terms of a dummy variable u, and then it becomes a bit more obvious that you've got to get 2 solutions. Takes longer, yep, but it depends on where you're at if you would like doing that sort of thing. That's that one. These I remember being quite tough, so we'll see how we go here. Only triple I, actually. Only triple I had a 12% pass rate. The rest of them were about 50-50, like most other questions in the exam. You're going to need to remember what f of x is, so we're hoping you've got the copy of your... You've either got it written down somewhere or you've got a copy of it. Let me know if you need like a screen grab or anything like that. So find the value of b. First thing you'd probably want to do is figure out where is b mentioned in the question, and it's there. It's a vertical translation in the positive direction of the vertical axis. So, with that in mind, we need to figure out how a vertical translation would look like to achieve that, and that'll be our value of b.
Chris, I don't know if this is a trick question, but isn't h of x and f of x, don't they have the same rules?
Yeah, h and f are the same rule. I might have misspoke, but it is you want to map h onto g.
Oh,
Yeah, I might have misspoke there. G is what you created with the reflection over here.
is b just 2?
B is just 2. Yeah. Why is that?
Because the amplitude of the function was 2, and then, yeah.
You chose B being 2 because of the amplitude being 2.
Like, because the amplitude is 2, right? Or the reflection. Actually, not, never mind. Yeah, I don't really know how to explain it. I just eyeballed it and said 2.
Yeah, I mean, that's fair, like even eyeballing it. Basically, if you're having a look at, F and G trying to push one onto the other. Let's see, what was it? This needs to be shifted in the horizontal direction and the vertical direction. So basically, yes, just shifting this up isn't going to get it a perfect overlap. That's where the horizontal is going to come in. Basically, you would see, cool, I need to get this blue line. Oh, sorry, I guess that's the black. Is it? Hang on. Yeah, it's the blue. You want to get the blue into the black. And so if you just can only do a vertical thing, then you want to get it up to that bit there. So up by 2, B is going to be 2. Like, perfectly valid to do that. It's a 1 marker. If you're more mathematically like algebra inclined, then you can start actually applying that transformation and then going, okay, well, I don't want to do anything horizontal, but I'm going to have this -1 plus b, and I want to make that equal to my g of x function, right? And since g of x is the reflection of f, then you just slap a -1 at the front of the entire thing, flipping both of those terms, and then you do your solve to figure out what b is. That's if you prefer the algebra approach there. But yeah, just looking at the function and just visually like picking a value is a pretty good idea. You can also do the same shit for A as well. But okay, if there's anything else to clarify, let me know. Otherwise, double I. This time A is the horizontal translation. So if you're imagining how you would like physically grab that blue graph onto the black graph, the only thing now to consider is how far left or right you want to shift it. The only key thing you're going to have to consider here is that you have to choose the smallest positive value for A. So there is a correct answer for shifting left or right. One of those is smaller than the other. It's not one of those things where you can have like infinite possibilities for your horizontal translation. You got to pick the smallest positive one. If you're having trouble eyeballing it, there are other ways you can make it work, mainly with the whole algebra thing. You stick in your horizontal translation in there and you make it equal to the function that you want to make it equal to. Right, so you're going to have the blue.
Is the answer pi?
Pi might work. It's not the smallest though.
Pi on 2.
Pi on 2 is the smallest, yeah. Now I still think pi would have been getting close to the right answer there. You might have just had 2a equals pi and then had to divide by 2 there. It depends on how you got there. So the way that I've prescribed in here is that whole translation method with the algebra. So you chuck in your horizontal translation in there, make it equal to the circular function that you want to make it equal to, and you can use some of the trig symmetry properties to help out with that. And so you can make these more easily comparable to each other by just saying, okay, if I expand this one out, I can now see that I have 2x minus 2a, and because when you have plus minus pi, positive sign becomes negative sign. This is a very involved way of doing it, by the way. I should probably fix this answer up to be a bit different, but it is a method of doing it, which is you say, okay, well, for this to become positive, this needs to be pi, and so you can shift it down. Probably the easiest way would have been to just say, okay, cool, I've shifted this up here. My peak is, in fact, yeah, do they have a 2 sine 2x minus 1? You could figure out where all these peaks and troughs occur pretty quickly. You get your period, you quarter it up, and then you figure out what would it take to get this blue peak to map onto this black peak. as far as the horizontal distance when you calculate both of those. That's a couple of things there. Did anyone have any other ideas on how to get there?
I kind of just considered the regular sine graph and how you would translate it. And I don't really know if I just got lucky though doing that.
Like, so when you said like the regular sine graph, are you looking at like this this
Like
blue?
from the origin. Like
Oh,
if you
regular
just,
sine.
yeah. And then I was like, you've translated up one already.
Yeah.
Then you have to move it in the horizontal direction. And to get the higher peak there, you would have to move it over by pi on 2. But I feel like that was kind of just the luck of the draw that I kind of got the right answer there.
I mean, maybe. The only difference between this sign and another sign is that it's shifted down. Because all else being equal, these have the same period. So whether you have it as a 2 pi period, like a regular sine, or a pi period, doesn't really matter because they're both the same. And so as long as you are considering what that looks like, it's kind of like how when you say your original solutions are like pi over 2 and whatever for solving circ, when you then go ahead and divide everything by 2 at the end, it then fits back into where it needs to be. So, you know, as long as you're still, yeah, this one didn't end up mattering too much for that because they had same period and and the vertical translation was already handled earlier. So that's pretty much it there. But fair enough. That's good. We're about to hit time there, so I think what I'll do. Yeah, we're not going to have nearly enough time to let you scramble around with that. There was a. It's not a hard trick. It's just a dumb trick. You got the answers in the thing. I think it'll be funnier if you give it a shot yourselves after this call if you have time. Keep in mind it was a 10%. Hang on, what pass rate? 12% pass rate. So if you don't get it, have a look at the answers in there, and then you'll either laugh at it or be very, very annoyed because it's what you'll have to cop in the real exam. And if the answer in there doesn't make much sense in my solution, let me know. Happy to clarify what that's all about. I think it'll be funny if you guys try it yourself first. Cool. I'll be curious to see if I get any text out of it. But anyway, that's that. We actually did pretty decently pace-wise for this, because I think there's only up to question 8 for this. Let's have a look. So you got question 7, which is some integral stuff. You got question 8, which is some more integral stuff. Yeah, we hit good pace on these. Like, considering that I sit and explain on all of them pretty much, the fact that we're still getting through this at a relatively good pace is, you know, it's nice to see. But alright, if there's anything further to clarify, I'll be here for it for a bit. Otherwise, I'll leave you to it. Take care.
Thank you.
No worries.
See ya.